In this video, we're going to practice a problem that starts looking at rotational acceleration and velocity, and then looks at how we can convert between uh, rotational velocity and linear velocity. All right, so the question that we're going to look at is the moon rotates once on its axis in 27.3 days. Its radius is 1.74 times 10 to the 6 meters. It has three parts. What is the period of the moon's rotation in seconds? What is the frequency of the moon's rotation in radians per second? And what is the linear speed of a rock on the moon's equator due, that's spelled wrong, only to the moon's rotation? So we're going to start with part A. What's the period of the moon's rotation in seconds? And this is actually just a dimensional analysis question. So this is from the beginning of the semester. We see that it's 27.3 days, and we want that in seconds. So all we have to do is find our conversion factors. So let's go first to how many hours in a day. So 24 hours in one day multiplied, it's an H, okay, by how many minutes in an hour. So 60 minutes in 1 hour multiplied by how many seconds are in a minute in 1 minute. And so we would multiply those together and get 27.3 times 24 times 60 times 60 equals, I'm going to put in scientific notation, so 2.35, or 36, I should round, times 10 to the 6th seconds. So it will take about 2 million seconds for the moon to turn all the way around on its axis. Now it's looking for the frequency. So how often does the moon go from here all the way around to here? And it's actually convenient that we did this problem first, because now we know in seconds how long this takes. And we know that because we're going all the way around the circle, as we've learned with radians, to get all the way around a circle, it is 2 pi radians. So for question B, all we have to do is, we know if we go all the way around the circle, that's 2 pi radians. And we're doing that in how many seconds? That's 2.36 times 10 to the 6th seconds. So 2 pi divided by 2.36 times 10 to the 6th seconds, we will get an answer of, this is a much smaller answer. I'm going to put in scientific notation though. So 2.66 times 10 to the negative 6 radians per second. So in other words, 1, 2, 3, 4, 5, 6. One, two, three, four, five. Yeah. So 0.0000266 radians per second. All right. So in other words, it's going pretty slowly. Now we want to think about what's the linear speed of a rock on the moon's equator due only to the rotation. So to do that, we're going to do our equation of velocity, linear velocity equals the radius times angular velocity, which is omega. So we just do the radius of 1.74 times 10 to the 6 seconds, or meters, times the angular velocity. I want you to do that, try it out. All right.